Okay, picture this. You've got an AI system, and it's stuck at a failing 50% score. Now imagine rocketing that up to a flawless 100% in literally 3 days. And we're not talking about simple trivia here. We're talking about complex tax law. In today's explainer, we're going to unpack exactly how a fintech company named Feather pulled this off. They built this incredible deterministic tax agent called Sheldon. And honestly, the way they did it is fascinating.
Right out of the gate, Feather ran into a classic AI dilemma. Do you let the AI just guess the tax rules on the fly? I mean, sure, that gives you 100% coverage instantly, but the accuracy is incredibly risky. Or do you take the other route, using AI entirely offline to generate the rules? That guarantees 100% accuracy, but you're starting from scratch with zero coverage. Since even a single hallucination on a tax return is a complete disaster, they went with the offline route. Absolutely crucial decision.
To actually make this work, they had to draw a really hard line in Sheldon's architecture. They essentially built a strict boundary that completely removes AI from the runtime execution path. So all that exact, unchangeable math, that happens in its own isolated environment, totally separated. Meanwhile, the AI is kept safely quarantined offline, entirely out of the real-time calculation loop.
Here's where it gets really clever. The AI is only used offline to read through dense English tax laws and translate them into JSON. Basically, JSON is just a structured set of instructions that a computer can easily understand. Once those instructions are locked in and verified, they get handed off to a fully deterministic interpreter. Now, deterministic is just a fancy way of saying the system produces the exact same, highly auditable result every single time it runs. Zero risk of the AI randomly hallucinating a new number during the actual calculation.
So let's see how this actually played out. On their very first run on the benchmark test cases, Sheldon scored exactly 50%. Now, in the software world, getting half the lines right on a first draft, that actually sounds pretty decent. But in the tax world, it's a whole different ballgame. A tax return with even one single wrong line is just, well, it's a wrong tax return. No two ways about it.
But the real magic here is how fast they rebounded. Because they were using this strictly deterministic setup, they didn't have to waste hours guessing why things were breaking. They could pinpoint the exact error, fix it, and literally rocket straight to a perfect 100% score in just 3 working days. Think about that. Those last 5 test cases went from totally failing to absolutely flawless in a single day.
How did they move that fast? It came down to a relentless 4-step methodology. First, they pinned down the benchmark so it was completely reproducible. Second, they made sure every single error was linked to a specific cause. Third, they forced themselves to fully decode the dense tax specs before writing any actual code. And fourth, the safety net. They built a parity harness to guarantee that fixing one bug never, ever broke something else by accident. Now, that third step, it actually forced the AI to decode some pretty wild tax trivia. Like, I had no idea the IRS taxes income at the midpoint of $50 bands rather than the exact dollar amount. Crazy, right? They also figured out that qualified disaster losses legally stack on top of the standard deduction, and early disability pensions actually count as wages for the earned income credit. And AI just guessing on the fly? No way it reliably nails those bizarre little mechanics.
But by isolating and solving all these quirks entirely offline, the system hit absolute perfection. When you look at the ground truth results, they scored 190 out of 190 exact lines across all 10 cases. And they did it all through encoded, entirely predictable arithmetic, and AI never even touched the final math.
Of course, as we all know, the math isn't the whole story. You could have a tax return with flawless arithmetic, but if it fails to print a required attachment or visually puts a net value where a gross value should be, you're still in trouble. That is exactly why they have an independent AI verification agent working right alongside a human CPA to review the final rendered PDFs. They act as that crucial final sanity check for the actual presentation before anything gets signed off.
Ultimately, the real breakthrough here is not just some static text engine. It is this rigorous, incredibly repeatable engineering loop. Decode the case, cite the law, write the rule, verify the output. It completely reframes how we should be thinking about generative AI in high-stakes environments. It proves that AI is incredibly powerful as an offline author, but honestly, it's just way too risky to be used as a real-time calculator.
Which leaves us with a pretty critical question as this kind of technology scales up. Knowing the real-world risks of AI hallucinations versus the absolute rock-solid certainty of deterministic math, how do you want your next tax return generated? Thanks so much for joining me for this explainer today. I really hope it sparked some new ideas on how we can actually build genuine trust into our automated systems.